Today we're looking at section 7.1, sequences and series. A sequence is a function whose inputs are consecutive integers. So that means one right after the other. Typically we don't even see the inputs, they just give us a list of the terms, which are the outputs. So like here would be our sequence of 5, 10, 15, 20, 25. We know that what we plugged in was 1, 2, 3, 4, 5. Unless they tell you otherwise, always assume that you start by plugging in 1. Two types of sequences are finite and infinite. Finite has a limited number of terms, so there's only a set number in there, it will stop. Infinite will go on forever, so that's where you see the dot 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 at the end. So if you don't see the dot dot dot, that means it's finite. If you do, it's infinite. Your first section of IXL is just going to ask you to find the first so many terms in a sequence. So you'll just start by plugging in 1, plugging in 2, plugging in 3, and listing out what you get. Probably the most challenging part of this section is writing a function. Right now we don't have any formulas for it. In the next two sections we'll learn some formulas for specific types of sequences, but for right now it's kind of guess and check. The important part when you're writing a function is that you are not describing what's happening from one term to the next. I don't want to know that you're adding 3, because if I'm adding 3, that only gets me to the next term. And if I want to get to something far down the list, that's going to be pretty tough to do. What you want to do when you're writing a function is you want to relate it back to what position it's in. So we're relating back 3 to the first position, 6 to the second position, 9 to the third position, and so forth. That way, when I want the 1000th term or the 323rd term, I can plug that directly into your function. So in this case, we're multiplying by 3, 1 times 3, 2 times 3, 3 times 3, 4 times 3. So now I can find ones further down the road, like 323 times 3 would give me 969. I don't have to sit there and add 3 and get 15, 18, 21, all the way down. Like I said, that part in this section will be probably the hardest part to do, just because there's a little bit of guess and check. Series is when we take the sequence and we actually add the terms together, so we just get one final number at the end. So a series is when you add all the terms together in a sequence. Once again, we could have a finite series, just plug in and we only have 4 terms and it stops there. Could have an infinite series that goes on forever. A lot of times we won't be able to actually find that sum, but we can have it go on forever and ever. A lot of times with series, you see them written with summation notation, which is just a fun word to say. Uses the Greek letter sigma, which is what looks like this capital E, but it's really an S in the Greek alphabet. That's just telling us that we're going to sum or add together our terms. Other parts of summation notation, we have our lower limit at the bottom that tells me what we start plugging in, and then we have an upper limit at the top that tells me where to stop plugging in. And then we plug into the equation that's listed after the sigma. So like in this first example, this is our equation, and we're starting with 1. We plug in 1, then we keep plugging in 2, 3, until we get to our top number of 4. So when we plug in 1, we get 2, plug in 2, we get 4, plug in 3, we get 6, plug in 4, we get 8, and we stop at that point. We would actually add those together to get 20 overall. In our second one, we have the dot, 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 so that's our infinite series. When we have an infinite series, we put infinity up above. Once again, a lot of times we can't find those actual answers. So if they ask you to write something in summation notation, you want to look and see how many terms you have. I always like to put it into a table form. This told me I plugged in 1 and got 7, plugged in 2, got 10, plugged in 3, plugged in 4, plugged in 5. That gives me a clear look at what I started with. I plugged in 1, clear look at what I ended with that goes on top, and then I want to try to find the relation between them for my equation. Other way around, if they give you your equation already and ask you to find the summation, then just go ahead, start plugging in with your bottom number. So I plugged in 4, plugged in 5, plugged in 6, plugged in 7, plugged in 8. I can stop there because that's my top number, and then add them all together for the end. That's one of your IXL sections as well. That one shouldn't be too bad. It might just take a little bit of time plugging things in. And then one thing to point out, if there's no variable to plug in for, like there's no x, there's no I, then you just repeat whatever's here that many times. When I plug in 1, I get 1. When I plug in 2, I get 1, because there's nothing to plug into. So it's just 1 every time. So I'd be adding 1 plus 1 plus 1, how many ever times it says to do that. And then these are 3 just shortcuts that you might come across that can help you formula-wise. Instead of plugging in a bunch of times, if it's just 1, you're just going to multiply whatever's there. If they're asking you to plug in, but it's just the single variable, then you can actually plug in n times n plus 1 divided by 2, and that will give you the same answer. Once again, just 3 shortcuts that you can always refer back to here. Looking at a few examples from IXLs. First section, like I said, is pretty straightforward. They're just going to give you an equation. In this case, it's 4 times 2 to the n, tell you where to start, and then ask you for the first so many terms. In this case, it's 5. So when I plug in 1, just be careful, follow the order of operations. 2 to the first power gives me 2 times 4, which is 8. When I plug in 2, I square the 2 and get 4 times 4, which is 16. Plug in 3, 2 to the third power is 8 times 4 is 32. Plug in 4, I get 64, and 128 when I plug in 5. Second section is going to be on your sigma summation notation. First part is going to ask you, is it infinite or finite? It's finite if it has a number on top. If it is finite, they'll also follow up a question with how many. Just count and see how many. If I start with 1, go to 32, there would be 32. Be careful if it doesn't start with 1. This one is finite still because it has a stopping point. It's tempting to just subtract these and get 31, but you do need to account for that first one there. So when you subtract and get 31, add one more to that, you'll get 32 for that as well. This one's an infinite series because it has an infinity symbol at the top. Once again, the hardest part's kind of come up with the equation. For IXL, for the most part, unless you go to the challenge section, they're just going to give you 4 choices. What you want to do is start by plugging in 1 and seeing if you get your first term. In this case, I get 6 from this first one, and then plug in 2. When I plug in 2, I get 3 squared, which is 9, times 2, which is 18, so that works. Plug in 3, plug in 4, plug in 5, plug in 6, make sure it works. Only one of these equations will work. So as soon as you get something that doesn't work, move on to the next. And then, like I said, finding the actual sum, you want to start with 1, plug it in. In this case, I would get 4 plus 3, which is 7. And you would want to keep track of that. And then just add the next term that you get. When I plug in 2, I get 8 plus 3, which is 11. And then keep going all the way until you get to 19. When I plug in 19, I get 4 times 19, which is 76, plus 3, which is 79. And then you would actually want to add all of those together and get your answer. Once again, be careful if they don't have a variable in it. You can only plug in 1 and get 33. Plug in 2, you get 33. Plug in 3, you'd get 33 all 10 times, so I'd have 10 33s. So this last one would be 330. Hope this helps. As always, if you do have questions as you work, please email me, create a Flipgrid, any way that you can to reach out. I'll gladly answer questions. Good luck.